This is the 10.4 lesson. So our teaching point is that today I'm going to teach you how to write an inequality statement to find the length of the third side of a triangle and whether three side lengths will form a triangle or not using the triangle inequality theorem, because not all side lengths can form a triangle. Okay, first of all, I just want to show you a very quick demonstration about triangles using some pieces of pasta. So I think oftentimes people think when you're given any three side lengths that you can make a triangle. So I'm going to actually turn this so you can see the entire piece of pasta is in my hand. So I'm holding it at the two very end points. And then I have two smaller pieces. But see, if I start at the end point, no matter how I try to get this, I'm never going to be able to make a triangle, because I'm just going to have to snap this last one in order to make a triangle. The other thing is, if make this one set up here for us, if the two small sides are exactly the same length as the long side, I don't have a triangle. I just have a piece of pasta sitting on top of a piece of pasta. In order for this to be able to pop up and make a triangle, these two shorter sides together have to be bigger than that long side. Otherwise, again, it would just match up and be one piece of pasta on top of another. So when you actually can make a triangle, the longest side is this one down here. The two shorter sides. So now I can make a triangle. When I put those two shorter sides all the way down, you can see when I lay these down, the two shorter sides are longer than the longest side when we put them together, so that then I am able to pop that up to make a triangle. So that's our thought process with today's lesson. And you would be exploring that more in class if you were in class today. Okay, so let's look at what that theorem tells us. The triangle inequality theorem states the sum of the two shorter sides of a triangle must be greater than the longest side of a triangle. Okay, so again, one of the shorter plus the other shorter, the sum, addition, of the two shorter must be greater than the longest. So let's look at this with numbers. If I look at these three side lengths, okay, here's the longest side, so I'm going to put that over here, 35. That means these two are the two shorter sides. So 14 plus 21 must be greater than 35 in order for these side lengths to be able to make a triangle. When I add these together, I get 35. Is 35 greater than 35? No, it's not. It's equal. That is not true. So that means the sum, let's write this up because this is going to be some justification here. The sum of the two shorter sides is not greater than the longest side. Therefore, they do not make a triangle. Okay, that would be a perfect example of the one pasta and the two other sides making the exact same length. It's just a piece of pasta sitting on top of a piece of pasta. Okay, this last example says to write an inequality. Okay, remember, got to think about that. Inequalities are these symbols. So I'm going to be using something like that for the third side of the triangle. And we know 2 of the sides are 12 and 8. We don't know the third. So I'm going to make an assumption here. Over here, I'm going to put them in order of least to greatest. So let's say 8 inches is the smallest, 12 inches is the middle, and let's say X is the longest side. So I'm assuming here that my unknown is the longest side. So the sum of the two shorter sides, that means these two are the two shorter, 8 plus 12 must be greater than the longest. Okay, now let's solve that. That's 20 greater than X. So that's one condition. But what if this isn't the longest side? What if it's the shortest? So now I'm going to put X as the shortest side. That means the 8 inches would be middle and the 12 inches would be the longest. So let's follow the theorem again. The sum plus of the two shorter sides, that means X and 8, must be greater than the longest. Well, now I have to railroad track to remember what we did in chapter 7 when we solved inequalities. Subtract 8 from both sides. And I get X has to be greater than 4. Okay, these are the requirements. I can write this all together. Here's how I'm going to do it. X is going to go in the middle. Now I want to think about what this is telling me. X has to be bigger than 4. X has to be bigger. So this opens always, the mouth of this opens to the bigger. So X is bigger than 4. Over here, X is not bigger. 20 is bigger than X. X is smaller than 20. X is smaller than 20. And I need labels. Inches, inches. And I write that together. As long as it's any value that is greater than 4 inches, so 4.1 inches works, but it has to be anywhere between above 4 and less than 20, I will be able to make a triangle with those side lengths.